Hey everyone, today we're talking about the Measurement and Uncertainty Lab from the Chemistry Lab Manual from Carolina Distance Learning. All right, so let's get started. The first thing I want to do actually is just give you a tour of how these experiments go. Let me just flip through it for you. And the first part actually is this first page is just a title page and it's really not necessary for you. So notice how it took all the toner from my printer. You might want to just not print these pages actually and not waste ink. After that comes an overview basically of the whole experiment, and it includes table of contents, an overview, what you're going to learn, rough estimate of the time that it'll require. Notice this one says it'll take over 2 hours. That means don't plan on getting this done in 20 minutes. Set aside a pretty good chunk of time to complete this experiment. Then after that comes the background section. The background section gives you all of the sort of prerequisite knowledge that you'll need to be able to complete the experiment. There's a bit of that information. Then after that, there's the materials that you'll need, so you can go through your kit and collect each of those things. And also, it's helpful to look this over, because if you don't know what something is, it might be nice to see what it looks like. If you didn't previously know what a graduated cylinder was, well, there it's showing you. Then a little bit on safety, and then this is where the activity starts. So from here on out is activity, but I want to show you one particular thing is that as you go, there's instructions, instructions, instructions. Then there's a table here, but then after that, in the activity are the data tables. So this is where you're going to record your data. So that's the next tip I'll give you is that I think it's a good idea to separate those out and set those aside so that when you're going through the instructions here, that you can record it on those data tables. All right, so the next tip is back at the beginning or back at the background section. Please, 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 please read this. I know that you're going to be tempted to just skip ahead and start the activity, but you need to go through this section. You don't necessarily need to read every word, but you need to skip through and make sure that you know what it means in each section. If you've used lots of scales and balances before, maybe you would skip this section, but then make sure you read about measuring liquids. There's a specific way we measure liquids in chemistry and a specific way we record those measurements, so that's really important. Make sure you know what the bold words mean. What's the difference between accuracy and precision? As you keep going, what are the different types of error? Do you know that? Do you know how we calculate that? Because here's some examples of how we calculate an absolute error and a relative error, or a percent error. So, which is essentially the same thing. Relative error can be raw numbers or in percent values. So, please read the background section. All right, so I'm going to go ahead and skip ahead now to the activity. I just wanted to make sure to make that clear that the background section is super important. All right, so now we're to the activity. And let's go ahead and start jumping through. And I'm not going to tell you every step in the activity, but I do want to call attention to a couple of things, because I don't want to make this video 2 hours long. I want to keep it 10 or 15 minutes. So I want to point out a few things here to make sure that we understand how it's going. So when you do the activity, just read each step and try to do it exactly as it's written. So the first step says, turn on your balance, allow the reading to stabilize at 0.00. All right, so find your balance. It comes in a box like this in your kit. Mine looks like this. Step one, you'll have to flip it over and put the batteries in. I've already done that here. There's one on both sides. There's two batteries, one there, one there. Then it has a lid on it. You're gonna pull that off and you'll have a balance like that. There's only 3 buttons: on, off, mode, and tare. Tare means set the balance to 0. Mode would change the unit, like grams, pounds, something like that. But most likely you're not gonna ever need to change that. We're gonna read in grams in chemistry and you can leave it there the whole time. So it says turn it on and allow it to come to 0. So I know it's not the easiest thing to see on this video, but you should be able to see now that it says 0.00 on the balance. says that the balance does not press 0. Say, I'm just going to set my pen on there for a second. If you open it up and instead it said 9.31, then what you do is you push that tare button, and that's what sets the balance to 0. So now, again, it doesn't read 0. So I'm going to press tare, it reads 0 now. Now it says label 2 plastic cups, 1 and 2. So grab some plastic cups, you can label them. It's pretty simple. They include these in your kit as well. And place the first cup on the balance and record the mass in data table 1. Okay, so let's scooch this over a little bit. I'm going to put this now on the side here, and I'm going to grab my data tables. So let's find data table number 1. Data table number 1. You'll see why you want this separated, because it's going to be really easy now to say, oh, record that mass. Well, let's set it on there, see what it reads. 10.3. So you'll see it bouncing around a little bit. You step back and make sure you're not bumping the table. Try to make sure there's no air blowing around. It should stabilize. And I get it stabilizing at 10.37. All right, so I mentioned air currents. Bumping the table can make the readings go a little wonky. Also, even just where you set the cup on the balance can make it read different sometimes. So sitting over here, it's reading something like 10.35. Over here, it would be something different as well. Usually you get your best readings right in the center. But for this experiment, you're sort of seeing what different things you can get. So you could choose to move it around on the balance if you wanted for each reading. Then it says, remove the cup from the balance, make sure it restabilizes 0. Mine did go back to 0.00, but if it didn't, you would press tare to make it go back to 0. Then you'd repeat steps 3 and 4. So just put it back on, record another value, etc. I'm just going to pretend like I recorded some other values here. Then it says do the same thing for the second cup. So you'd come over here for the second cup, record some values there as well. Now it says determine the average mass. So you would add these all up, divide by the total number of 5 to get the average mass, which would be some number. And as you're going through here, just a reminder, it's a good idea, well, you definitely should, record the unit behind any number in this class. So this was 10.37 grams. Now I know in this particular instance, it says grams up here, so you're going to say that's redundant. You're kind of right. But down here, you're going to be, in this data table, you're going to be taking a mass and then a volume, then a volume, then a volume, then calculating an uncertainty, then a mass, then a mass. So here, you can't always do that. So better than saying, oh, well, here I can get away with it because I know they're all in grams, you should just always write the unit after the number. Just always do that in a chemistry class. Okay, so from there on out, the instructions should make sense. What it's going to have you do is calculate the deviation from the average, which it explains to you here and should be relatively straightforward. You're going to the deviation from the average, which you're going to calculate over here, is the average mass of the cup minus the mass of cup in the trial. So you'll take that average, subtract 10.37 from it, and that'll give you the deviation from the average there. Notice the 2 lines out here mean absolute value. So if you get a negative value, just make it a positive value. And then you'll go ahead after all those deviations, you'll get an average of that as well. All right, so you should be able to go ahead and do that. One more note here. A lot of times people get hung up looking at the data page and like, deviation from average, what do I do there? What do I do there? Where if you're following along with the activity, it didn't tell you what to do here. Well, when you do step number 9 and finish recording the masses, well, calculating the average masses, then flip over here, and the next steps will probably tell you how to do that. So don't think you have to know how to do this ahead of time. The next steps are very likely telling you what to do in that next column when you get there. I remember when we're live in class, I always ask students, well, what was the last step when they ask questions, a lot of times we say, well, what was the last step you did? And they're like, well, the last thing I did was right here. And I say, well, what does the next step say? And then, and then they read it and they're all, oh, dang it. Obviously that's what I need to do. So try to ask yourself that same thing when you're at home. When you get stuck, say, well, what was the last step I did? And then what's the next step? Can I just go one step at a time? And you'll probably be able to get through these. All right, so let's go on to activity 2, because this is what I really wanted to spend a little time explaining how this goes, because it's kind of an odd way to have gone about this, but I think we can make it make sense. So activity 2 says turn on the balance again. And I'm setting it on the paper so it's in the video, but you'd be better off setting it on a hard surface like that. So it says turn on your balance, allow the reading to stabilize at 0. Place the 10 milliliter graduated cylinder, so look in your kit and find this. It's a graduated cylinder. The way you know it's the 10 milliliter one is there's a number 10 right there. Hard to see on the video, but you'll see it easily in person. Place it on the balance. They're calling it glassware. This is obviously plasticware, but write down the mass of that. So record the mass in data table 2. So mine says 10.54 grams. And go on. So the next step says remove the graduated cylinder from the balance. Add approximately 7 milliliters. So grab some water, grab your graduated cylinder, grab some water, and pour in. It says approximately 7 milliliters because you really don't have to get right on 7. It doesn't matter that much. To be honest, if you added 6 or 8, this next part would work exactly the same way. So if there's any bubbles in it like I got, then you might want to tap it or swirl it or something to try to get rid of that bubble. So there we go. I got rid of the big one at least. There's still a couple little ones hanging on. So now you want to record the volume of the water. So if you read the background section or have watched some other videos in this class, you should know that the way we do that is we always look at the markings shown and estimate the next digit by seeing where in between those markings the volume level is. So to do that, I'm going to grab my camera and rotate it around now and see if I can get a look at exactly where this water is. Now it's hard to focus here. So this is kind of the next tip in the line, is that you're seeing my camera's having trouble focusing. You may have trouble seeing it as well. There we go, I got a good focus. So you have a couple options here. You can grab solid color papers or even solid color papers with other lines on them like this, and it's a little easier to get a focus then. Because I don't want to use both hands, and that's pretty easy to see where the water's at if you do it this way. Sometimes it's actually best to hold the solid cup thing a little bit below it. It kind of highlights the line. Sometimes it's best to hold the solid color right behind it. So I don't want to hold that. So I'm going to grab this, and hopefully this will work, and see if I can get a good focus back for us. All right, that works. All right, so I'm going to come down in line, and you can see here that it has markings, and I poured more than 7, which is totally fine, at 8, and then there's 1, 2, you can barely see this one, 3, 4, and then the next marking is at 9. So those must not be 0.1 each. If they were 0.1 each, it would be like 7.0, 7.1, 8.0, 8.1, 8.2, 8.3, 8.4, and then you wouldn't already be up to 9. So they must be 0.2 each. 8.0, 8.2, 8.4, 8.6, here 8.8, and then 9.0. So that's what we're looking at there. So this one is somewhere, it's not super easy to tell, but the bottom of that meniscus curve, where you see the water curving down, where we always read some, is somewhere between the 8.4 and 8.6 mark. So if we have water somewhere between the 8.4 and 8.6 mark, you got to kind of imagine what's going on there. We're trying to estimate this next place. So that's 8.60, 8.40. And you got to kind of imagine halfway in between would be 8.50. Halfway in between that would be sorry, I'm going to bring that out over here. Halfway in between that would be 8.45. Halfway in between that would be 8.55 as you're counting up. And you got to kind of imagine where exactly that line is in that process and make sure you're always going, if the markings went to the first decimal place, 8.4, 8.6, that you're estimating one digit beyond that. And that's where the variability will lie. So if we look back at this, it is hard to tell, and that's not a problem. You are estimating here. So it's somewhere, to me it looks a little bit past the 8.50 mark. So I'm going to say something like 8.52 is what I'm going to go ahead and write down. I think it's 8.52 grams. Now, you might have said something a little bit different. Okay, so the video cut out there for a second. What I was saying is that you might have said something a little bit different. Maybe you would have said 8.50 or 8.55, and that's totally fine. That's what this next part is about. So as you go on, we just added the 7 milliliters, recorded the volume of the water. Now it says record the highest and lowest volume interval. So and it gives some more information about that. It says use the graduation lines on the glassware to help determine the higher and lower interval. So that's what we were doing down here. We aren't sure that I estimated that last digit correctly, but we do know that the water was somewhere between the 8.40 and 8.60 lines. So that's what we're going to write in, 8.60 milliliters. And I'm sorry, I just noticed now that I had grams there. That should be milliliters. The low volume interval is 8.40 milliliters. So chemists really don't prefer this way of doing things in general. We prefer to do what we did up here, where you take repeated measurements and then use some statistical measures to understand how much variability there is in a measurement. But in this case, they're just wanting you to have a basic understanding here that we're estimating this digit, but it's not 100% clear how exact we are. So tell me what you know for certain. This is what you know for certain, that it was somewhere between these two lines. And then you'll calculate the uncertainty. How do you do that? Well, there are different ways to do that, but like we were talking about earlier, let's see what this lab tells us to do. It's right there in the instructions. The next step says calculate the uncertainty of your measurement. Calculate the uncertainty as the high volume minus the low volume divided by 2. So take this minus that. When you subtract that, that'll be 0.2 divided by 2, and in this case, 0.1 milliliter. So what we're trying to get here is that we know that this was an estimate. We know that it's somewhere close to that number, but there is some possible variability depending on sort of the angle I was looking at the water, how good of an estimator I am, my experience, a lot of different things. But that's basically what we're trying to get at here. It's just a quick, rough measure of how much variability might have been included in that measurement. So that's the main thing I wanted to do on video. The next steps are pretty straightforward. You go back to your balance. You put the cylinder with the water back on there. Measure it. Mine weighs 19.02 grams. Then you find the mass of the water, which the instructions tell you is the mass of the glassware with the water minus the empty will give you the mass of just the water. So you know the volume of water and the mass, and that's what you're going to use in this next step. I'll leave that for you. Thanks for hanging with me. See you next time.